Hello, welcome again. Let me चल गया. Hello, welcome back in this series of mole concept, lecture number 7. So in the last class we have discussed the concentration terms and we have done the numericals of the concentration term. So today what we are going to do, we will try to understand a little bit about the atomic weight and then we will see some basic concept of Agiometry. Okay, so let's start and have a look. So this is the lecture number 7 and let's start with the atomic mass determination. So how to do the atomic mass determination? So the first method is called as Dulung Patek Law. See, for the NEET exam point of view, you don't need to understand the detailed method of Dulung Patek's law. So what you need to understand, it is used for the metal atomic weight determination. It can be applied for the metals at high temperature. So it is applied for the metals at high temperature. Now let's see how to understand this. Okay, so we have this equation, which is a very good equation. So you need to remember for the NEET exam this formula, that is the atomic weight of metal into specific heat equal to 6.4. So in the exam, if it is asked how to calculate atomic weight of metal, atomic weight of metal equal to 6.4 upon specific heat capacity of metal. So specific heat capacity, so you just need to, these all value will be given to you, specific heat will be given to you of the metal. You just need to divide the 6.4 with that value and you will get the atomic weight. And there is another method, or other methods for the molecular mass determination. How to calculate the molecular mass experimentally? So the method is Victor-Meyer's method, only for the volatile substances. See, Victor-Meyer method is valid only for the volatile substances. Now how will you calculate? See, in this case we have this and this is the Victor-Meyer tube. What is happening actually, we have the volatile substance here which is vaporizing because of the volatile nature, and then this is vaporizing and it is going into the water and then it is displacing some air. So it is displacing some air. So what is happening in the reality, that liquid is vaporized, volatile liquid is vaporized, then it is going here and then water is replacing the air. So this gas or the volatile substance which is displacing the air, actually it is facing the surface tension of the water. So surface tension of the water is hindering it. So for getting the exact pressure of the gas or the vapor of the liquid, we need to subtract this water vapor pressure, which is of course we are having this in it. So see, we will have the barometer here, let's say barometer we will have here, and we will measure the pressure. When we will measure the pressure, that will include itself a surface tension of the water. So now see this is very simple equation. If you have I have told you that the important equation of the gas is PV equal to nRT. And pressure volume equal to weight upon molar mass RT. Then molar mass will be WRT upon PV, which is something this. So see, WRT, pressure, volume, and this 760 to convert this into the ATM. If you want to convert it into ATM, this is converting into the ml, milliliter. So 760 and 1000 are nothing, they are just the unit conversion factor. And this formula is very similar to this. Now the question arises, why we have here this P minus small p. See, the barometric pressure, barometer, which is the measure, like instrument to measure the pressure, it will give the pressure capital P. And we have the aqueous tension of the water into it, because this liquid is passing through the water. So this barometric pressure will have the total pressure, it will give the total pressure of the barometer, aqueous tension, and the pressure of the dry vapor. So now if you want to calculate the pressure of the dry vapor, what we need to do? Total minus the surface tension. Total minus the surface tension is small p, and we will get the pressure of dry vapor. So we will get the pressure of dry vapor. Now this is, we got the pressure. So ultimately each term is now clear. So in the exam it will given to you that what is the weight, temperature, and the pressure, barometric pressure, aqueous tension of the water, and the volume. You just need to calculate the molar mass. Now this is the important method, silver salt method. So how will you do this, understand the silver salt method? Okay, so for the silver salt method, let's see what is happening here. See, this is, if I will write the monobasic, which means we have one replaceable hydrogen ion, only one. If I am saying the dibasic, then I have two replaceable hydrogen. Tribasic, then I have three replaceable hydrogen. Now see, my dear students, this will react with AgNO3, and it will, what it will do, it will just make Ag, and then after heat it will deposit silver. So see how, what is the logic behind it for determining the molecular weight. The very simple logic, which is based on the, of course, mole concept. So let's say this silver salt weight is W gram, and this silver which is deposited is X gram. Now I can write X gram Ag is deposited from W gram silver salt. So this is the salt and this is the silver. X gram of Ag is deposited by W gram of Ag silver salt. So 1 gram of Ag will be deposited by W by X gram of salt. Now, what is the atomic weight of Ag? Atomic weight of Ag. (108). So 108 gram Ag will be deposited by W into 108 upon X, because 1 gram of silver is deposited by this gram. So 108 multiplied by just 108. Now you will say, what is the profit of doing this? So the profit is that this is actually the molecular weight, or I would say atomic weight. So it will give the information that if we want to produce the per mole silver, we require the per mole of salt. So this is actually the molecular weight of salt. So we got the molecular weight of the salt, which is Ag. Now let's see what we need to do. So in this case, what is our motto? Our motivation is to find the organic acid molecular weight. So we got Ag. So we need to replace this Ag and just add the H. So what I will do, W into 108 upon X, remove the silver weight 108 plus 1, which is the hydrogen. So I can write that molecular weight or mass of acid will be something W into 108X minus 107. This will be the exact answer. Now let's see. Now you people will surprise, then what is this N value? See, this N value is the basicity. This n value is the basicity of the acid. Okay, so this n value is the basicity of the acid. Now if we have the dibasic and tribasic, then what will happen? See, HNA, it will react with the silver AgNO3, it will give AgNA, then NAg is deposited. NAg is deposited. So it is very simple. So this factor n is coming from there. So I can just use this. So I can write, let's say this is the W gram and this is the X gram. This is the W gram and this is the X gram. Now see what I can write. What I can write? I can write this very easily, that X gram of NAg is deposited by W gram of AgNA. 1 gram of NAg is deposited by W by X gram of AgNA salt. Okay. Now if I will talk about the 108 gram, let's say this is NAg. So this will be, let's say, NW gram, because this is NX. Okay, just a minute, just do it. Okay, so now 108 gram, like previous one, of NAg will be deposited by 108 W gram by X, this much of AgNA salt. This much of NAg, like this much of salt we will require for NAg deposition of 108 gram. So if we require 108 gram of this NAg, okay, so the total weight is n into 108. Okay, so because this is the weight of 1 silver, so total is n into 108. Here we require n also multiplication for n. So now what I can say, so n into 108 Ag will be deposited by n into 108 W by X, or you can just simply multiply here by n. Okay, so now the same method, you need to remove the NAg because this is the molecular weight. So you will write n into 108 W by X minus n into 108 and add n times 1. So ultimately you will have the common value of n, which is the here, and the rest you have understood this. So rest is the same. Okay, so this is one method. Then another method is platinic acid method. What is the platinic acid? Platinic acid is H2PtCl6. It will react with the acid and it absorbs two base molecules. So it absorbs the two base molecules. So we have B means what is base. So platinic acid method used for the organic bases. So we have two bases in this molecular formula. So when we need to calculate the atomic weight, we need to calculate this molecular weight of this organic base. In this salt we have two bases, two base. So what I need to do, I need to divide it by 1 by 2 for one base weight. When I want to calculate the weight of one organic base, it contains two base. So for the one I need to divide by 2. That's why we have this factor divided by 2 in this case. Let's see, don't worry about it. I will just explain like the previous one. Then we will heat this and it will deposit platinum, and atomic weight of platinum is 195 gram. So I can directly write W gram 195, or this is X gram, let's say X gram of platinum will be deposited by I would say W gram of H2PtCl6 B2. Okay, this much salt. Similarly 1 gram will be W by X, 195 gram of platinum will be W by X into 195, this much. Then my dear students, so 195 gram will be deposited by this much of salt. So this is what? The atomic weight, this is the atomic weight, or I would say the molecular weight of this B2H2Cl6 PtLCl6. So for B2 what I will do, I will just subtract this. If I will subtract this, which is something 410 something or more than that, okay, more than that it is, okay. So of course I need to remove that. So W into 195x minus 410, and now this B2, this now the remaining weight is, this remaining weight is for this B2 and it has two bases. So for the one base I need to divide it by 2. So similarly, if there is n type of base or n base factor, or the acidity of this base is n, so you need to multiply the n factor, so you will get this n factor like the previous one case, in this case. So this is how you need to calculate the organic base. Now see, some students are asking, sir, we are unable to balance the combustion reaction, so for the hydrocarbon. So the, see, always hydrocarbon, what are the hydrocarbon? The compound which are made up of the hydrogen and the carbon. When they react with the oxygen, that will form carbon dioxide and the water. Carbon dioxide and the water, and this is how you can balance these reactions. So I would suggest to remember this reaction, it will be really useful for you. And now let's come to the agiometry. Agiometry, it is a very important concept. In this type of question, what you need to do, you need to just remember the chart. What chart? In this chart, you just learn that KOH is absorbing CO2, sulfur dioxide and Cl2. Ammonical CO2 is absorbing CO, turpentine oil O3, and alkaline pyragalol O2, and water is absorbing ammonia and HCl, anhydrous CuSO4 CaCl2 is absorbing water. Okay, so before moving forward till this point, if you have any doubt, just let me know. Is there any doubt? So this is 𝐕𝐏𝐾 law holds good. Dealing may be done in volume and gas analysis. Dealing may be done in volume, and this is the gas analysis. So remember, dealing may be done in the volume. Okay, and this is what you need to remember, which solvent absorb which gases. Okay, now let's see. This is a very good question. 40 ml of gaseous mixture of CO, CH4, neon was exploded with 15 ml of oxygen. After treatment with KOH, the volume reduced by 9 ml. See, in this case, with the oxygen only these two react. This does not react with the oxygen. Neon does not react with the oxygen. You need to remember, and slowly you will see when we will move forward in the chemistry, you will be able to understand these things. Okay, so let's see. Carbon monoxide reacts with the half oxygen, it will give CO2. Okay, and if I will talk about CH4, it will react with O2, it will give CO2 plus H2. So we have this something. Now let's say X ml of this we have and Y ml of this we have after writing the reaction. Or now X ml of this reacts with 1 ml of the 1 mole of this reacts with half mole of oxygen. So X ml will react with X by 2 ml of oxygen. Similarly, my dear students, CH4 1 mole is reacting with 2 mole. Similarly, we can treat them with the volume. So 1 YmL will react with the 2 YmL of O2. That's the important point here. Now read this equation, this line. This is exploded with 15 ml of oxygen, and after the treatment with KOH, the volume reduced by 9 ml, which means there is some gas which is absorbed by KOH. What that gas could be? So that could be carbon monoxide, CH4, carbon dioxide, water and neon. Anyone from this. Let's see from our chart. So in our chart it is saying that KOH is only absorbing the carbon dioxide. So now I can understand that this is going to absorb the carbon dioxide. So how much carbon dioxide? It is 9 ml carbon dioxide. That's why KOH is used 9 ml, or it reduced the volume 9 ml. So 1 ml is going to form X ml of this, and this is Y ml is going to make Y ml of this. So now I can have the equation X plus Y, which is the total 9 ml. Total carbon dioxide is 9 ml. And then another thing what we have, my dear students, it is saying on treatment with alkaline pyragonal, the volume further reduced by 1.5 ml. So pyragonal absorbs the oxygen. So that means this is the unreacted oxygen which left. Unreacted oxygen. Unreacted oxygen. This is the unreacted oxygen. Now see, one equation we have X plus Y equal to 9 ml. Another equation is total oxygen is X by 2 plus 2Y, and unreacted oxygen is 1.5. And it is given that initially the total oxygen was 15 ml. So I can write this equation 15 ml. Now just do the simplification of these equations. 4y plus 3 equal to 15. So X plus 4y equal to 12. Now X plus Y equal to 9. X plus 4y equal to 12. Minus minus minus, it is going to be cancelled out. Minus 3y minus 3, so y equal to 1 ml. What is the y? Y is the CH4. Okay, y is the CH4. Okay, so why it is 1 ml? Let's see the equation again. Is there something wrong we have done? So okay, so it will be 30. Okay, so we have written this wrong, so it will be 30. Just a minute. When you will take the LCM of this, it will become 30, and 30 minus 3 will be 27, my dear students. So it will be 27. So here it will be 27. Okay, let me do it for all of you. 27, and what you will get, 27 9, it will be 18. It will be 18. Okay, 18. So it will be now 6 ml. So CH4, how much CH4 we will have? We will have 6 ml. Now percentage, we have 6 CH4 percentage, we have 6 ml this, and total is 40 ml. So 40 into 100, 0.00523, which is approximately 15%. This is how, this is the best method of aidiometry. In case of aidiometry, you just need to understand which solvent is absorbing which gas, and then just apply the what? Just apply the concept of mole concept, which we have seen. Of course, that can be principle of atom conservation, that can be the stoichiometry method, any method. Then we have, what is the molar mass of diacidic organic Lewis base B if 12 gram of its chloroplatinate salt is ignition produced 5 gram of platinum? See, this is very simple. You just go here. In case of organic base, which is here, this is. So you know the W. What is W? W is the mass of salt that gives X gram of platinum. So X is given, W is given. What is the W? Let me see. What is the W in this case? So W is 12 gram and X is 5 gram and N is 2. Just put these value, you will get the answer. So in the today class, we have seen, of course, the little advanced topic. Okay, which is important from the NEET exam point of view, but not from the CBSE point of view. So just read them and listen this lecture carefully so that you can solve the question. Okay, so we will meet on next class. Have a good day. Best of luck.